To build an AI voice assistant that feels like a natural human partner, you have a strict physical limit, 200 milliseconds. That is the maximum pause allowed before a conversation starts feeling awkward and robotic. Standard retrieval augmented generation systems blow past this limit immediately. Querying a remote vector database over a network typically takes between 50 and 300 milliseconds. Before the large language model even starts generating a single syllable, your entire conversational time budget is gone. The AI research team at Salesforce built an open source architecture to bypass this network delay entirely. It's called VoiceAgentRAG. The system works by physically separating two distinct tasks, fetching information from your database and generating the actual voice response. Achieving a natural conversational flow doesn't require forcing the language model to process tokens faster. It requires structurally removing the document retrieval step from the critical response path. A single spoken query enters the system and is managed by an asynchronous event bus. This bus instantly splits the workload into two parallel tracks, a foreground path and a background path. Looking at the top path, we see the fast talker foreground agent. It handles the immediate conversation by restricting its search to a local in-memory cache. By avoiding the external network, it locates context in 0.35 milliseconds. While the fast talker speaks, the slow thinker background agent operates on the bottom path. It continuously analyzes a sliding window of the last 6 conversation turns, using that context to predict 3 to 5 likely follow-up topics. Based on those predictions, the slow thinker reaches out to the remote database. It pulls relevant document chunks into the local cache before the human user has even finished speaking their next sentence. By answering questions using data it secretly prepared seconds earlier during natural conversational pauses, the system creates the illusion of zero latency intelligence. To make this work locally, the system relies on a specialized semantic cache built with an in-memory face index flat inner product configuration. The background agent doesn't predict direct questions. Instead, it generates document-style descriptions. This ensures the resulting embeddings align closely with the actual text structure found inside the knowledge base. When configuring the cache similarity threshold, the math dictates a specific cutoff. The default value must be set to exactly tau equals 0.40. You are measuring the similarity between a short conversational query and a dense document chunk, rather than comparing two similar queries. Because of this, the cosine similarity scores are naturally lower. If you set this threshold too high, the system will reject valid context, resulting in a 0% cache hit rate. To prevent the cache from bloating, strict hygiene rules apply. The system identifies near duplicates using a 0.95 similarity threshold and clears out old data using a least recently used eviction policy with a 300-second lifespan. These indexing and threshold parameters guarantee that the local cache will recognize a relevant document, even if the user asks their question using completely different vocabulary than the background agent predicted. For the remote vector store, the architecture natively connects to external databases like Qdront Cloud, mapping standard 1536-dimension OpenAI embeddings. A predictive system eventually guesses wrong. If the human asks a completely unexpected question, the fast talker checks the local cache and registers a miss. The exact moment this cache miss occurs, a priority retrieval event triggers. The background agent drops its predictive tasks and executes an immediate synchronous fetch from the remote database to answer the user. During this emergency fetch, the system uses an expanded top case strategy. It grabs twice the default number of documents from the remote server, aggressively pulling a large contextual buffer centered around the new topic. This failsafe means you take the 110 millisecond network penalty exactly once. By overfetching on that initial miss, the system repopulates the local cache and ensures all subsequent follow-up questions return to that 0.35 millisecond response time. When you boot the agent and start speaking, the terminal logs reveal exactly how traffic routes through the system. You will see an initial unpredictable query output, a cache miss with a 110 millisecond delay, followed quickly by a cache hit log processing at sub-millisecond speeds. Across 200 benchmarked queries and multiple conversational scenarios, the dual agent architecture maintains an overall 75% cache hit rate. This bar chart illustrates how conversational focus impacts performance. Looking at the towering 95% hit rate, we see a sustained feature comparison scenario. Here, the topic remains consistent, and the background agent's predictions are highly accurate. Now watch the performance drop to 45%. This represents an existing customer upgrade scenario. The user jumps erratically between different topics, pricing, technical specs, and contract terms, causing the predictive cache to miss more frequently. The primary variable controlling latency is conversational volatility. As the human focuses their line of questioning, the AI's predictions lock in, and memory access becomes virtually instantaneous. Over a standard 200-turn conversation, bypassing the network for 3 out of 4 questions physically eliminates over 16 seconds of dead air. The framework is strictly stack independent. Developers can easily swap the default OpenAI setup and route logic through Anthropic or Gemini using the built-in integrations. For maximum security, you can pair the VoiceAgentRAG architecture with local Ollama embeddings, cutting external connections entirely to build a fully air-gapped, zero-cost voice assistant. Mastering this memory routing architecture solves the hardest physical constraint in audio AI. You stop waiting on the network and start building fluid conversational partners.
Please like, share, and subscribe.